Taking this question from the November 2016 grade 12. A learner constructs a push toy using two blocks with masses 1.5 kilograms and 3 kilograms respectively. The blocks are connected by a massless inextensible cord. The learner then applies a force of 25 newtons at an angle of 30 degrees to the 1.5 kilogram block by means of a light rigid cord, causing the toy to move across a flat, rough horizontal surface as shown in the diagram below. The coefficient of kinetic friction between the surface and each block is 0.15. 2.1. State Newton's law, the second law of motion. So the net force acting on an object is equal to the rate of change in its momentum. 2.2. Calculate the magnitude of the kinetic frictional force acting on the 3 kilogram block. Let's draw a free body diagram for the 3 kilogram block. We have a normal force, we have the weight, we have friction acting in the opposite direction, and then we have tension. Since this block is pushed towards the right, so it means that the system will shift to the right. So friction always acts in the opposite direction. And then F of k is equals to UK multiplied by the normal force. The normal force is in the y component. So we will say sum of the forces that are on the y component is equals to 0. The system is moving to the right, so there's no movement in the y component. That's why the acceleration is 0. This is normal force minus Fw is equals to 0. So the normal force is the force of weight, which is m multiplied by g. So this is u, m multiplied by g. 0.15. The mass is 3 multiplied by 9.8. 0.15 times 3 times 9.8. So this is 4.41 newtons. 2.3. Draw a labeled free body diagram showing all the forces acting on the 1.5 kilogram block. That's 5 marks, so I'm expecting to have 5 arrows. We have a normal force, we have the force of weight, and then in this direction I have the F applied, and then friction acts in the opposite direction, and I also have that string there, that cord. So this is the force of tension. So I have 5. 2.4.1. They want me to calculate the kinetic frictional force acting on the 1.5 kilogram block. Okay, here let's include the other option. So this is the normal force, this is the force of weight, we have F of tension, we have F of k. So if I were to draw a Cartesian plane there, you will notice that this force, it is neither in the x or the y axis. It is just somewhere there. And whenever I have a situation like that, it means that I need to resolve this into its components. So I will have F applied, that is parallel, and I will also have F applied, that is perpendicular. So that if I draw a Cartesian plane like that, this is the 25 newtons force that is being applied, and then I'll have one that goes in that direction and the other one that goes in that direction. So this I'll have that, and the other one will look, no, it will look like that. So this is F applied parallel, and this is F applied perpendicular. Now they are looking for the kinetic frictional force. We said Fk is equals to mu k multiplied by the normal force, and the normal force is in the y component. Sum of the forces that are acting on the y component is equals to 0. I have a normal force there, and then I have the weight in the opposite direction, but I also have F applied perpendicular. So this will be F applied perpendicular, which is equals to 0. So this means that the normal force is equals to the force of weight plus F applied perpendicular. So now I can substitute. F of k is equals to mu k multiplied by the force of weight plus F applied perpendicular. This is 0.15. The mass, that's 1.5 multiplied by 9.8 plus, this is 25. And then when you use trigonometry, you know that whatever is in your y, that is a sine of what? Of an angle. So this is sine of 30 degrees. This is 0.15, 1.5 times 9.8 plus 25 sine of 30. So I'm getting 4.08 newtons. 2.4.2. They want the tension in the cord connecting the two blocks. So that is motion in the x-axis. So it's the x. Sum of the forces that are acting on the x is equals to max. So now we'll start with the 3 kilogram block. We have the force of tension. We also have F of k. So this is going to be F of tension minus F of k, which is equals to ma. The force of tension, we don't know what that is, but this is 4.41 from here, from 2.2. We know that this is 4.41. The mass, that is a 3a. So this means that the force of tension is equals to 3a plus 4.41, which is equation 1. And then now for the 1.5 kilogram block, sum of the forces in the x component, which is going to come back here. So I have F applied parallel, F applied parallel, and then that subtracts the force of tension plus F of k, which is equals to the mass multiplied by the acceleration. This is 25 cos of 30 degrees minus the force of tension, that's what we are looking for, and then this is 4.08, which is equals to 1.5 a. 25 cos of 30 minus 4.08. So this I'm getting 17.5706 3509, and then this is going to be 1 plus k. So this is this side, that's gonna go. So this is a minus 1.5 a, which is equals to the force of tension and that is equation 2. The force of tension here should be equal to the force of tension there. So I'm going to equate the two. This is 3A plus 4.41, which is equals to 17.57063509 minus 1.5. So this is minus 4.41, which is 13.16063509, and then this is going to be 4.5a divided by 4.5. So the acceleration is equals to 2.92 meters per second squared. But they are not looking for the acceleration, they are looking for the tension. So I'm just going to take 2.92 plus 4.41. This is 3 times 2.92 plus 4.41, and then I'm getting 13.17 newtons.